Hi everyone, and thanks for joining us today for my talk on getting up and running with gRPC in .NET Core 3. Tonight I'm going to go through a bit of the background on gRPC, some of the history, where we've been, some of the downfalls of, and the reasons why this is a story that keeps growing. I'll introduce you to gRPC and how it promises to solve those problems. And part of that, we're going to compare and contrast gRPC with one of the common RPC technologies at the moment, being REST. And we'll see how gRPC compares to that story. And then finally, the bulk of this talk is about getting up and running in .NET Core 3, and that's where we're going to finish up there. So, like Penny said, my name's Elliott. I'm a solution architect here at SSW. I've been here for 2 years now. I have been in the world of enterprise development since 2005. So that's .NET 2.0. From there, not long after there was WPF. I spent a lot of my early career in WPF. All of that time has been in the world of enterprise development. So I generally don't sort of stay away from the apps and the personal websites, but it's all enterprise development there. These days, my tech stack's .NET Core with either Angular front end, React front end. It's very web-based now. So we mentioned earlier that the NDC videos dropped. We had a big presence there at NDC. It was pretty awesome. It's always good fun to go. I had a great opportunity to interview and to talk with Scott Hunter, the Director of Program Management at Microsoft. And I got a great insight into what the big changes for .NET Core 3 were. And one of those was the introduction of gRPC, and that sort of spiked my interest, and that's where the basics of where this talk has grown from. So I had a great chance to talk to both Scott Hunter and James Newton-King. So James is the world-famous author of the Newtonsoft JSON serialization library. He's now working for Microsoft, and the author of the gRPC story inside .NET Core 3. So I had a great opportunity to talk to both of those about everything that we're going to cover tonight. Personally, I am a father of two. I've got a daughter 3 years old and a son who's just turning 2 in the not too distant future. And they take up the majority of my life, and you may see a bit of a theme down the track in the demo that shows that, that's where my mind is at the moment. Another interesting fact, I like to push myself. Endurance running is one of those things that I like doing these days, out on the trails. So I have completed 4 6-foot track marathons. It's a lot tougher than that sounds. It's not 6 foot. It's actually 45K, and it's in the Blue Mountains. So it goes up. We start up, we go down, then we go up for 15K, then a bit of down, then a bit more up, and then down. They say it's equivalent of about a 60K run. So you put me up here, I've got the endurance, I'll keep talking all night long if you need me to. Otherwise you can shut me up and we can move on. The other thing at NDC, at SSW, we released our rewards app. Awesome application. It had great feedback, great traction at NDC. If you hit that QR code, you can download the application for both iOS and Android. Matt here in the audience is the author of that. He did a great job. Basically, you can scan each of us SSW consultants. You can earn some points. You can earn points by coming to these events, by coming to our talks. There is a special QR code at the end of this talk that will score you even more points. The reason you're scoring points is because we have some great giveaways. There's some fitness bands, some drink bottles. I think we're even giving away some of our training events, so at certain rewards levels. So I urge you to download that app and start chasing us down for some points. But let's get into it. So what is RPC? So if we're going to talk about gRPC, let's start at the very basics. What is RPC? And basically, RPC is when I need my program to talk into another program. So we're crossing program boundaries. and I need to access resources or to issue commands across those program boundaries. So doing things like fetching data, initiating a command, and basically anything that I would like to do within my local application. So let's go back in time, not all the way back to the beginning of any RPC request, because, as Greg said, he's been around for 100 years and been doing this since the 1960s. I'm not going to go that far back in time. But back in 98, we see the introduction of XML-RPC. It's not overly fast. XML is not an efficient language. It's very, very inefficient, quite repetitive, and communication via XML is not fast at all. 99, we see an introduction with the SOAP protocol, still XML based, but we start to see some contracts in place now. 2000 is around when we start seeing the introduction of a REST API. But we've moved away from having contracts. So our REST APIs are there, and if we adhere to the REST standards, the RESTful approach, they become predictable, but there's still no clear definition of what our API looks like. In 2002, Microsoft released remoting, binary transfers, so we get a bit more speed involved, and we're making progress. 2005, there's the introduction of JSON-RPC. Obviously, JSON's more efficient than XML, so we do get a bit of a speed increase. And 2006, Microsoft introduced the Windows Communication Foundation, leveraging the SOAP protocol. 2007, I've thrown REST back in there, because that's when we see the introduction of our Swagger docs, or these days it's known as OpenAPI. And that's now reintroduced the contracts back into our REST endpoint. So now we can have a more discoverable approach to discovering our REST endpoints. I've highlighted that in bold because that's pretty much where the industry started to stabilize on. Then enter 2016, Google start thinking, okay, well, REST's all well and good, but it's not great. So Google throw their hat into the ring. They introduce serialization technology called protobuf. They're playing around with new transport layer protocols, which turned into HTTP2. And they've released a very fast, very efficient RPC technology, gRPC, and that's what we're going to focus on for the rest of the talk. So let's talk about the common pitfalls of RPC. So if we're talking communications between two programs, sometimes things don't work well, and we might have a few issues. Does anyone here any examples of something you might think of as being a common pitfall that you've come across in the world of RPC?
Contract changes.
And versioning? Yep, it's a big one. Usually the very first one everyone thinks of.
Network failure.
Yep. Port 135?
Yeah,
No, I've blocked that off. It doesn't exist. It's not my problem. So network instabilities. Yep.
Framework dependencies.
Yep. So single platform, cross-platform communication, definitely. So I've got a few here. So some of them lacked contracts. They're not discoverable. Slow, inefficient. So at REST in particular, it's based on HTTP. But the big one there is versioning. And, there's a few things that I think everyone's in agreement that there's downsides with RPC. What I want to show is how gRPC attempts to alleviate these headaches. So gRPC to the rescue. First question everyone asks is, what does gRPC stand for? The simple answer is, it stands for gRPC Remote Procedure Call. The G doesn't stand for anything. I hear that because Google did introduce gRPC, they invented it. But these days, they're trying to take a step back. They don't want to tarnish the brand, so to speak, of gRPC, and they want it to be used ubiquitously. So they're taking that step back, and they're being very silent. That's the story I've heard, and that's what I'm sticking to at the moment. So how does gRPC alleviate some of these issues for us? First up, it uses two technologies that Google actually had a big hand in. So HTTP2 came out of the Speedy protocol that Google were working on to speed up our transport layer. And protobuf is our serialization technology. So we're going to go into those in a few more slides. And using the combination of all these technologies, it ends up being a very high performance framework. And as Matt alluded to earlier, most RPC technologies could be very platform dependent, very framework dependent. gRPC is actually designed as being cross-platform from the ground up. Now, one thing I learnt at NDC talking to James Newton-King is that anyone that's creating a library, a framework that has a library for gRPC, there are strict testing going on in the background to be able to release a framework that supports gRPC. So when Microsoft make changes to their code, it goes up into the repo and it gets tested, integration tests against all of the other clients to make sure that it's compatible across the board. So it's really interesting. It's one of those things I didn't know and I only found out at NDC, but it's one of those things that they've put a lot of effort to make sure that it is cross-platform. So let's have a look at REST versus gRPC. So when we're creating our REST endpoints, we're generally starting from a resource first. So if I'm creating a REST endpoint to fetch all my locations, I'm generally going to start at that point. I'm going to create my location endpoint first. Then I'm going to create my contracts as a secondary citizen to the actual endpoint. So I'm going to use the OpenAPI documentation tool, but that's creating my contracts based off the content, the endpoints that I've created. What that results in is, one of the big things is human readable content. So I can see the wire transfer and I can actually open up those payloads. And when I'm doing my debug story, I can actually see the payloads that are going through and I can make sure that it's showing the data I want to see. However, our contracts are not so human readable. Yes, they're in JSON, but has anyone tried to open up a Swagger doc and tried to make sense of it? It's not fun. So yes, they're human readable, but they're not really human consumable. And it's using text serialization. So we're talking JSON payloads. But for me, one of the big things is our REST endpoints make a big point about being hosted on or being transported across the HTTP layer as a transport layer. So we're using the HTTP verbs. They're very first-class citizens in the predictability of our REST endpoints. And we've had great discussions in the office here about success codes or HTTP codes being sent back, about what verbs you use. If I'm working with a CQRS backend and I need to issue a command, well, what verb is it? Sometimes is it a post, is it a put? You know, people get a few, it can get heated. It's probably the easiest way to say that. So where does gRPC come in there? Well, using protobufs, gRPC is contract first. So we're not creating the endpoints first and then generating the contract. We're actually going, as I'm going to show, we're going to create the contract first, and then I'm going to create my services based off those contracts. What does that mean? It means that the contracts are human readable. I can give anyone in this room my protobuf file, and you should be able to interpret what's going on in that contract. Unlike REST, if I give you the Swagger doc, yes, you might be able to work it out, but you're not going to try. But it is binary serialization. So you're not going to be able to easily see what's being transferred across the wire. And yes, it does use HTTP2. And it leverages the speed and the performance benefits of HTTP2. But it doesn't make a song and dance about it like a REST endpoint does. So it's there, but you know, it's just there. It doesn't matter. So questions downstairs we had about the comparison between a JSON payload and a protobuf payload. Now, here's a slide from Nils Magnus on GitHub where he's compared the payload size of a JSON object, JSON serialized objects, versus a protobuf serialized object. So the blue line, the very first blue line, it's very high. High is bad in this instance. High is how big the payload is. So you can see there that the blue line, the JSON, and the orange line, which is the protobuf, there's quite a big difference. It's significantly more efficient as a payload because we're talking a binary serialization versus a JSON serialization. What's more interesting on this slide, I find, is the last two columns compared to the first two. So the last two columns are the same payloads, but being gzipped. So what's really interesting is actually comparing the orange and the gray line. So the orange line is the raw protobuf file, and the gray line is the zipped JSON. And the raw protobuf file is still more efficient than a zipped up JSON.
It's also interesting showing because there's not much compression.
Yep. So
Very efficient.
yeah. So because it is binary, it's not going to compress as well as a text document. However, it's not really relevant because it's more efficient than what the text-based document is. And so how do we get the benefits, or what benefits does HTTP2 offer over HTTP? So I've mentioned that one of the big differences between the two technologies is that gRPC is leveraging HTTP2 to offer its performance benefits, but what benefits are we getting? So first up, HTTP2 allows us to compress our headers. So there's a lot of text in there. We can compress those. We've got smaller payloads. We get binary framing, so now we can start sending binary data along our HTTP connection. But the big one there, for me personally, the big one here is the request multiplexing. So I've got a slide to show that, but what that does mean is we avoid the head of line blocking. So if I've got multiple HTTP requests, each HTTP request requires one TCP connection to make that request. And if my HTTP connection request is blocked, then that TCP connection's tied up until that one's finished and nothing else can come in. Whereas with HTTP2, I can make multiple HTTP requests across my TCP connection. And whilst the first one's blocked, the second one can still continue, and so can the third. So what that looks like in practice is, as you can see in this waterfall diagram, is the top line, we can see that very staggered approach of HTTP1, where I need to make my serial requests to the server. Compare that to the bottom line, which is where I can make more parallel requests across the same HTTP connection.
Are they to the same scale or should not?
No. So that's how we can get some performance benefits and how it compares to a REST endpoint. Now, there are other things that gRPC can add to the picture for us. So there's several modes of communication. First mode is what's known as unary communication. I make a request to the server responds. It's very much like a REST endpoint. However, I can also have server-side streaming. So I can make a request to the server, and the server can stream results back to me. So would anyone have any idea where that might be useful? I find people usually come back and say maybe video streaming, infinity scroll type streaming, or actually that'll come down later, I guess. Large result sets, I find. So if I want to make a request to the server, it can drip feed me the results. If there's a long running query and it can start bringing back results, I'll get those results sooner rather than waiting for that whole query to finish. We can have client-side streaming. Very similar. I can start making a streaming request to the server. And then when I've finished, it will send me the results back. So any thoughts about ideas around, yep, log streaming's common?
Patient vitals.
Sorry?
Patient vitals.
Patient vitals, yep. So the example I usually come up with is IoT, which is probably very similar in that respect. So my IoT device constantly just streaming up sensor results or whatever needs to go up to the server. And the final mode of communication is bidirectional streaming. So we're combining both our server-side streaming and our client-side streaming. Suggestions? Any thoughts? There's one really obvious one. Chat programs is probably your most common example there. Who wants to see how we can get this up and running in .NET Core? Yeah, that's why we're here, isn't it? Okay, so here is my demo. First thing I'm going to show is my protobuf file. So I have a file suffixed .proto. And as I mentioned earlier, my mind is around my kids at the moment. So this demo, it's about returning back kids' characters from the kids' cartoons and who they're interested in. So what we can see here is I'm defining the syntax of this file. First up, it's a version 3 of the proto file. Because I'm going to create C# libraries out of this. I'm defining the namespace in the C# libraries we'll use. The package that this is going to be deployed as is a kids characters. The important one here is this service. So this service is the RPC endpoints that my service will expose. So I'm going to have a characters service. It's got an RPC endpoint. And first up, it's going to be called getCharacter. And getCharacter is going to take in a character request. And it's going to return a character response. Pretty simple. Like I said, these are very human readable. So what is a character request? Well, it's a message. And it's got an ID of 1. Sorry, it's got an ID, which is an integer. And the response returns a character, which is of type character. And we can see here, the character is defined here. Now, we mentioned earlier that one of the big issues with RPCs is our versioning story. So protobufs have gone about this in a really smart way, in my opinion, as to how do we avoid versioning issues. And that's simply done by providing an index of each property. It's pretty simple. It's pretty straightforward. If I need to add a new property, I can just add. I usually have show off there. Right? I can add another property. Anyone that's built against my previous version, they're not going to see it. They're not going to know it exists. Anyone that's built against the new version and gets sent an older version, they're just going to fill in what the default value is for that one. Okay? So it's pretty straightforward.
So what does that value 5 mean?
That property is indexed 5, is the 5th property inside that serialized object.
So if you decide to remove show at this point.
Okay. If I remove that, nothing changes.
Yep.
However, I would not recommend removing that, because what that's showing is that property doesn't exist. Now, if I leave the company and someone else comes along, they see a gap there and they think, oh, I've got a new property. I'm going to add age here. Now I have actually broken my contracts because I've changed the object that was actually serialized in there. So if I've got an old version that had show and they're passing in, and I'm now expecting age,
Yep.
we're going to actually have something broken. So I'd still leave it in there.
I want to change show to expose because I've got naming issues.
Yep, that's fine.
Anything else?
That's fine. The name's fine. You can change the name, just don't change the meaning. Yep, don't change the meaning of that property, but you can change the name to whatever suits you. Correct. And that's I guess what I was trying to convey there is if you do delete it, there's nothing to say this was deleted for a very good reason. I'd probably just because humans. Exactly.
Can I put a comment on the end of the line saying reason why you shouldn't use this anymore?
No.
Let's just have a look. I don't know.
//
No.
Hey,
Okay. So let's get rid of that because that's not actually part of the demo. Okay, so if I save that. So now we've got our service definition. And I hope you agree that is pretty human readable. Compared to a Swagger doc, I'd much rather read one of these guys. So now in my solution, I've got two projects. I've got my server and my client. Both of these I have just created by going File, New Project. The client is an empty console application. There's nothing fancy about it. My server is an ASP.NET Core application. And I don't want to do that just yet. But it's just an empty application. There's nothing turned on. It's just a very bare bones ASP.NET server. So let's now add a definition for that service. So what Microsoft have done, what the team have done in VS19, if I double click on connected services, and I go to service references, I've got these two options now. You'll notice one is Open API, so if I do have my Swagger doc, I can do the same code gen here. But tonight we're talking about gRPC, so I'm going to add my gRPC reference. And you can drag it in from a URL because this is our contract. If I want to expose that to the greater world, they can reference it from that URL. Here, because I'm doing it inside the one project, I'm going to reference that from the directory. And down the bottom, I can choose to generate a server. I can choose to generate my client code. I can choose to do both or just the messages. Okay. It is smart enough to realize that this is a service. So it, by default, has chosen server. So I'm going to click OK. And that's going to generate me, it's going to add it here. Now, what has that done? That's done several things. And I did this earlier because internet connections with demos you're not quite sure about. One of the first things it does do is drag in these three packages and configure these three packages from NuGet for us. So it's dragged in the protobuf definition, the ASP.NET Core server definition, and gRPC tools. gRPC tools is the code gen tools to create our service, our server and our clients. So it does all that for us. We don't even need to think about it. I just wanted to show that it's there. What else has it done is, if I click on the C# icon, it has auto-generated all my services for me. So all the boilerplate code. You can see the namespace is demo. It's created a partial class called characters, which is the name of my service. And it's given me another abstract partial base of characters base. So let's implement our first service. So let's just add a class.
Where's that generated into? Is that Proto's virtual folder?
That has been generated. No, that virtual folder is a link back to here.
I see.
So that's gone there. No, I've just created that character service. So this guy is... I don't know. Interesting.
I think don't you specify the path when you do the generation, when you do with a code set?
By default, you don't have to.
You don't have to.
You don't have to. So that's all configured up in close that, save. It's all configured up in here for us. Okay, so I've created my character service file, and what I want to do is implement demo.characters.characterBase, that base class we just looked at. And that's dragged in, that's done all the boilerplate stuff to do everything we need to define a character service. But ultimately, now all I need to do is override. And if you can see that, the second option there says get character. So that's already populated, created the base, the abstract for us for that get character service. We can see it returns a task of character response, which we defined in the proto file, and it takes in a character request. So those objects, they're already created for us, they're already there. So just a few other things to get my application up and running. Let's give me a database. And now let's just update that to fetch the desired character from my list. So we're looking into the request, grab the ID, and then just return that as part of the response. Pretty straightforward. So when I save that, I can get that up and running. And while that's running, so building and running, let's have a look at what the client looks like. Sorry, that's not going to run. Sorry, I missed one step there. We need to actually configure gRPC. We need to tell our server how to run gRPC. Being .NET Core, it's very simple. We just say services.add. So now we've turned it on. We're very simple. Now we need to expose that service endpoint. So another introduction for .NET Core 3 was endpoint routing. Has anyone used endpoint routing? No. Matt. So one of the conversations that I did have at NDC was around this endpoint routing. Now, Microsoft, well, not Microsoft, sorry, the .NET team, the ASP.NET team, realized that the routing inside our ASP.NET applications was sitting at the MVC layer. Right? So if I needed any form of routing in my server, I needed to implement MVC. But as Scott kept saying, not every application needs a model, a view, or a controller. For instance, this application, I don't need a model, a view, or a controller, so why do I need to drag in the rest of the MVC pipeline? So what they've done is moved our routing outside of MVC up a step into the ASP level. So what that's done has now allowed that whole, the HTTP pipeline to get involved with our endpoints. So yes, I'm going to just add my endpoint.map gRPC service. I can map that service. And now that's come into my application. So now I've exposed that gRPC service from this application. What that does allow, though, is it's now tapped into the rest of my ASP.NET pipeline, my request pipeline. So if I need anything along the lines of any other of the middleware that comes with that, we can now actually utilize inside our service. So I can start to bring in authentication too on my service. It's a very easy story to add. So now when I run that and save that, let's just redo that. Now let's add our client. So here's my demo client, and I'm going to do the same thing. I'm going to add a connected service, And I'm going to point to the exact same file. So we're sharing the same definitions. This time, I'm going to select client. Again, it's smart enough to know that I want to create a client because I'm in a console application. We can look at the built code again. Very similar. So let's now create our demo client. So instead of watching me type everything out, I'm just going to go here. First thing we want to do is create a channel. So we're going to open up that communication with our server. Very simple, just ask for a JSON-RPC channel and give it the endpoint. Next thing, I need to create a client for this specific service that I'm calling. So I'm going to ask for the characters client, and I'm going to tell it what channel to use. Then finally, we just need to make our request to that client. So this guy is just one line. I'm going to asynchronously call my get characters. I'm going to pass in that request. And then we get that result. So if I were to run this up, you can see my endpoint gets called, and you can see the results there. So that's our unary operation in place. So let's have a look at server-side streaming, the second mode of operation. So to do that, I'm going to add another endpoint, and it's as simple as just adding a search endpoint. This time I've got my RPC service, search characters. It takes in a request, and it returns a response. But the thing to highlight here is we're defining that it's a streaming response at this point. So now we're going to stream our responses. So the only thing I need to do is add my search request down here to say, okay, we're going to pass in that string as our query. When I save that, I can come back to my service. You'll notice if I do override, it's not there yet because my code gen only works on a build. So I just need to build it. Build that, and then I can add my search service. Did that not? Let's stop that. There we go. So make sure you stop that service when we build. Okay. So let's have a look at the search characters request. This time, we're not returning the response, we're just returning an asynchronous task. But we do take in a server stream writer of that response type, is one of the parameters that come in. So when we do make our requests, I'm going through the results, and then I can asynchronously write each result to that stream. Okay. And then I've just got a delay in there so we can see a bit of a delay. Speed that up, slow it down. So now we're just going to write one response, wait 1.5 seconds, write the next response. So when I save that, and let's get that up and running. And so how do we talk to that service? Let's go back to our client. Just comment those out. And I'm going to add my search. Okay, so here it's a little bit different. when I do call into the search characters, it returns a request. And it returns an async server streaming call of that response. So where'd it go? Okay, so I can create that search request, pass in my query. Then I can use one of the new features of C#8, the async enumerable. Okay, so part of the gRPC package in .NET, they've got an extension method called readAllAsync, and that returns us an async enumerable. So I can just put my await outside that for each, and it's just going to asynchronously iterate across that list as those results come in. Then we're going to write those lines. Okay, so let's save that. And this time, when I run my application, you can see those results coming back one at a time, and you can see the handler stepping through each of those requests as those results come in. Pretty straightforward. They make it really simple for us. So naturally, the next option is to look at the client-side streaming. Now, I wasn't smart enough, imaginative enough to come up with a good example here for client-side streaming. So the simple example I could find in this world is if I want to send up a stream of numbers, stream of integers, and when I send anything that's not an integer, I just want it to give me the result of that, the sum of that stream going up. It's a very simple endpoint, and so my requests are integers, and my response is just going to be a number. Save. Let's stop that. Rebuild, so our services, our code gen gets kicked off. Now let's have a look at what the server for creating a client-side streaming is. So this is kind of what we'd expect. My result is a task of the sum response, which is very similar to our first request. And this time we're passing in an iasync stream reader. So here I'm using my asynchronous enumerable to read that stream coming in, like we saw on the client, but this time we're doing it on the server. I'm adding each to the count, and then once we get that last request in, then we're going to close off our stream, and I'm going to send back to the client that result. So let's get that up and running.
So did you see the stream identified?
The stream is passed in here as a parameter.
Yeah.
And then we're reading asynchronously from that. And when that stream finishes,
So
when the client terminates the connection.
correct.
right.
And we'll see that in a sec. Okay, so let's get that up and running. So back here, let's have a look at how we do that from the client side. Let's leave that in there. Now my client looks a bit more complex. So first thing I'm going to do is call that endpoint, which is going to give me my async streaming call. Okay, so now this is my stream. I am asynchronously writing each request to the stream. And then once we've finished, I close that stream off. I send that complete signal down the wire. Okay? And then that's when the server knows that that asynchronous enumerable is finished, and we get that result.
But you have to physically.
You do have to close. You have to send that complete signal. So the client is in control of when that's finished. So when we build that and run, oh yeah. So if I hit 5, so you can see the numbers getting received on the server. And then when I hit anything that's not a number, that closes that connection, the server finishes its job, and then sends me the result back. And so I mentioned earlier the fourth style, which is the two-way streaming.
So you can split that to running total.
Yep. But the actual implementation of that's a lot more difficult because we have to actually make sure that one stream's not blocking the other stream. We don't end up in this deadlock, which in the amount of time we have tonight, that's a bit too much of a demo to get into. But it's not much of a stretch of the imagination to work out how to turn this to a bi-directional streaming. And that's as simple as adding the word stream there. And now I have a two-way streaming server. One of the other things that I didn't mention that I like looking at on here is when I do spin up my server. So let's stop that. When that starts up, you will see that it's discovered the get character service. Sorry, the get character method on my character service, and it's discovered it's unary. It's discovered the search characters that's server streaming, and then it's discovered my do sum, which is client streaming. So our server's telling us exactly right there what it has found on that proto file for us. So let's jump back. So I hope I have shown through that demo and by digging into the proto files, I hope I've shown how gRPC promises to solve our versioning issues by discussing the cross-platform nature of our of the gRPC environment. We're no longer single platform. Utilizing current technologies, utilizing the performance benefits of both HTTP2 and binary serialization of our protobufs, we've eliminated the other downfalls, the inefficiencies, and the slowness of our previous incarnations of RPC. So I mentioned earlier, we do have that application, our rewards app. If anyone is trying to score points and you would like a bonus 500, here is a QR code. It's a limited time offer. It's going off the screen very soon. And so this will earn you 500 more points to claim against the rewards. Does it work? You'll need the app first. You will need the app. I can bring this slide back up after the talk. So tonight I started with a brief history of RPC. I didn't go back 100 years, Greg, but we did go back to the, early 2000s? Late 90s. I've introduced what is gRPC and what problems it was trying to solve and how it has solved them. I compared and contrast the gRPC versus the current common favorite being REST and the technologies, the serialization, and the benefits we do get from the binary serialization, the HTTP2 transport, the benefits that gRPC does offer over REST. Finally, I showed the efforts Microsoft have put into Visual Studio to show how easy it is to get, not just Visual Studio, sorry, but ASP.NET too, to show how easy it is to get our gRPC services up and running. This is a technology that's got me excited. I was excited after talking to both James and Scott about this technology, and it made me want to get in and dive deep into this technology and ultimately come up with this talk. I can't wait to actually use it in anger. I can't wait to really see the benefits that it can offer myself, my clients. I hope you guys can. I'd love for you to contact me and tell me about your benefits, about your experiences. I am active on Twitter at the moment. I'm currently at 97 followers. I'm hoping after tonight I can get over 100. That'd be pretty awesome. But I hope you've had a great takeaway, and thank you for coming.